Okay, this is the solutions to the Chapter 15 final exam review. There was definitely some difficulty grade-wise on this review, so I thought I'd just do a video of all the solutions for everyone. So number one, we have this reaction here, 2HCl plus magnesium hydroxide makes magnesium chloride plus water. Water's liquid, everything else is aqueous. And the equilibrium concentrations are 1.5 molar for HCl, 1 molar for magnesium hydroxide, and 2.5 molars for magnesium chloride. And the question says, what's the equilibrium constant? So remember, we're going to take the concentration of the products raised to the power of the coefficient. So we're not going to use H2O because it's a liquid. You don't include liquids and solids in calculating K. So this would be the concentration of MgCl2, which is 2.5 molars. That's going to be to the first power, which you don't have to write. And then in the denominator, the reactants, the concentration of HCl, which is 1.5 molar. And that is going to be squared because the coefficient is 2. And then times the concentration of MgOH2, which is 1 molar. That'll be to the first power since the coefficient is 1. And if you put those in your calculator, you got to be careful. I did have one or two students show the work correctly, but ended up messing up in their calculator. But it would be 1.11. Now the unit for this is going to be molars, the top, over molar squared times molar. So that'd be molars cubed, and that will reduce to 1 over molar squared. Now I would have accepted it also asked part B of the question. So this is part A. Part B says, is this reaction weighted, the equilibrium weighted towards the products or the reactants? So it's greater than 1. So it's weighted towards the products, but only very slightly. So if you put products or neither, then I accepted that. Okay, so each part A and part B are worth 4 points each. I could give you some partial credit for part A, but not any partial credit for part B. All right, so that's number one. Let's take a look at number two. All right, number two, I didn't even write actual compounds in there. We just have 2A, which is a gas, plus 3B, which is a solid. We'd have 2C, which is aqueous, plus 2D, which is aqueous. Okay, the concentrations are measured. 1.2 molars. Okay, we don't care about B because it's a solid, so it's not part of calculating K. 0.8, and for D, 1.6. It says that the equilibrium constant is equal to 3.5 molar squared. So is the reaction at equilibrium? So we just need to calculate K with these concentrations and see if it's equal to 3.5. All right, so K for this reaction is going to be the concentration of C, 0.8, squared because of the 2, times the concentration of D, 1.6. That's going to be squared because of the coefficient of 2. And then the concentration of A, which is 1.2 molar, and that's going to be squared because of the 2 out front. All right, when you plug that into your calculator, be careful. Most people got this, but I did have one or two people miss this. be 1.14, and the unit is going to be, actually you know what the unit is because it's m squared, it was given, but it'd be m to the fourth because you have m squared times m squared on top over m squared, so that would just reduce to m squared. So that is not equal to 3.5. So it's not at equilibrium. We need the equilibrium constant to get bigger. We need the numerator to increase. That means the products need to increase in concentration so that we can get bigger up to 3.5. So the reaction must shift right or towards the products. All right, so that one is, this is part A for that one, and part B is which way should it shift. Each part is worth 4 points, A and B. I could give you partial credit for A, but I couldn't give you any partial credit for B if you missed that. All right, so I think I can fit number 3 on this board before I erase. So number 3, we have give the expression for the equilibrium constant, but you don't have any numbers here, any concentration. So we have NH4Cl, which is a solid, and our products are NH3 gas and HCl gas. Okay, so it's just the products over the reactants. So K is going to be the concentration of NH3, coefficient is just 1, times the concentration of HCl. And then on bottom, we don't include because it's a solid, so that's just over 1. So you could just write NH3 and HCl. Most students did get that. I think I had 1 or 2 miss that one. All right, so you did have to remember to not include the solid. Okay, I'm going to erase this, and we'll move on to number 4, and which is Le Chatelier's principle. Okay, number 4, we have this reaction. NaCl, so sodium chloride, which is aqueous, plus liquid water, plus CO2, and that's going to make NaHCO3. Okay, which is aqueous plus hydrochloric acid. Okay, so part A says what will happen to the concentration of CO2 if HCl is removed. So we're going to remove HCl. So what will happen then is if we remove HCl, there are fewer collisions on the right, more collisions on the left. So the left side would win, and the side that wins gets the hose. All right, so they get to point the hose to the other side. So we want to know, in this case, what happens to the concentration of CO2. All right, so if CO2 is on the left side and the hose is pointed the other way, CO2 will decrease. All right, had a mixed bag on this. I think most people did pretty well on number 4. Okay, but I'm sure at least a couple of people probably missed that one. All right, part B. says what will happen to the amount of H2O. So we want to know about the amount of H2O if the concentration of NaCl is increased. So we're going to increase NaCl. What's going to happen to the amount of H2O? Now, a few people looked at H2O and said, oh, that's a liquid, so nothing's going to happen. Well, you can increase and decrease the amount. You just can't stress a reaction by changing the amount of H2O. But we change the amount of an aqueous substance. Okay, so if I increase NaCl, then the left side will win. The left side will get the hose and shoot it towards the right. So that will end up decreasing the amount of H2O, all right, because it's on the back end of the hose. All right, so I know I had a few people, certainly not more than half, but a few people did say nothing would happen because H2O is a liquid. You needed to think about that on part C, which almost everyone missed. I think maybe only 2 or 3 people got part C correct. It says what will happen to the concentration of CO2, all right, what will happen to CO2 if more H2O is added. Okay, so we're adding H2O and nothing will happen, because you can't stress a reaction with a liquid. All right, so the answer on part C was nothing. Okay, then part D says what will happen to the concentration of HCl. All right, we want to know about HCl over here at the end. If more NaHCO3 is added. Okay, so we're going to increase or add to the concentration of NaHCO3. Well, that's going to make the right side win. The right side gets the hose because there's more collisions over here. Okay, so we're going to shoot the arrow this way. The winner gets the arrow. They're going to shoot it the other way. Well, what's that going to do? That's going to, if it's shooting the other way, that's going to decrease concentration of HCl. All right, so the answers are decrease, decrease, nothing, and decrease for part 4. You know, pretty good on this, but definitely a lot of people missed part C, and some people missed other parts as well. All right, so race number 4. Let's take a look at number 5. So there we have 2ClO. And that makes Cl2 gas plus O2 gas. And on the last one, each one of those parts is worth 4 points, and there's no partial credit on that. So Cl2 gas plus O2 gas, and it says that delta H is negative 100 kilojoules, so that means it is a product. So energy is a product. The negative just tells you it goes on the right side and not the left side, and that's important for number 5. Okay, so anytime you have energy, we're looking at changes in temperature. So part A says what will happen to the concentration of ClO. So what's going to happen to ClO here if the temperature is reduced? If the temperature is reduced, the equilibrium shifts towards the side with the energy. So if the temperature is reduced, the reaction will shift, in this case, to the right. Okay, so what will happen to ClO? It's going to decrease since the hose is pointed to the right. All right, part B says, what will happen to the concentration of O2 if the temperature is raised? If the temperature is raised, the equilibrium shifts away from the side of the energy. So what we're interested in, which is O2, is on the back side of the hose, the back side of the arrow, so that O2 would decrease. A lot of people got this one, but a few people did miss it, so hopefully this was a good explanation for you. Again, parts A and B are both worth 4 points each, and so there's no partial credit on these. If you missed it, it's the full thing. If you had taken the Chapter 15 test, it would have been mostly a no partial credit test, mostly multiple choice, and I think each one of these types of parts are worth 5 points each on the test. All right, that's number 5. Let's take a look at number 6. All right, number 6, I gotta maybe write a little smaller here to get all this. This is a wide one. So you got 3 TiO2, which is a solid, plus 4C, which is a solid, plus 6 Cl2, that's a gas, and that makes 3 TiCl4. You're probably fast forwarding through this part, plus 2 CO2, right, which is a gas, and the phase really matters on this one, and 2 CO gas. All right, all of these questions, these 4 questions, are about pressure. And when it comes to equilibrium, what we want to know about pressure is how many gas moles. Well, on the left, we have 6 gas moles. I hope you can see that green. In fact, let me find a different color. All right, on the left, we have a 6. Cl is the only gas, so 6 gas moles. On the right, they're all gases, so 3 plus 2 is 5, plus another 2 is 7 gas moles. All right, part A says, what will happen to the amount of TiO2? So TiO2, the first one, if the pressure is raised. If the pressure is raised, the reaction shifts away from the side with the most gas moles. So it's going to shift away from the right. So what's going to happen to TiO2? Well, the hose is going towards it, so it will increase. The amount will increase. Not the concentration, it's a solid, the amount. All right, let's look at part B. What will happen to the concentration of Cl2 if the pressure is decreased? Well, if the pressure is raised and it shifts to the right, if its pressure is decreased, it's gonna, or shifts to the left, it'll shift to the right. Okay, shift towards the sides. If pressure is decreased, it shifts toward the side with the most gas molecules. So the question asks, what will happen to Cl2? All right, and since it's on the back end of the hose, it would decrease. All right, part C says what will happen to the concentration of CO. Okay, CO is all the way over here to the right. What will happen to the concentration of CO if the pressure is decreased? Well, we've already figured out if the pressure is decreased, the reaction shifts toward the side with the most gas moles. So the hose is pointing towards the right, towards CO, so it would increase. And then part D says what will happen to the amount of TiCl4. So that's the first product. If the pressure is raised. If the pressure is raised, the reaction shifts away from the side with the most gas moles. So the hose shoots to the left, and that's going to cause TiCl4 to decrease on the back end of that hose. Okay, so the answer on number 6, increase, decrease, increase, decrease. Okay, I know I had a couple of students who, instead of only adding up gases, added up all the moles. And the solid moles don't matter. So that forced them to get every single part wrong. Okay, but all 4 parts, A, B, C, and D, are worth 4 points each. There's no partial credit on this one. Okay, and most people didn't show any work anyway, so they just wrote out increase or decrease. A few people showed some arrows and things like that. All right, that's number 6. That one definitely caused some problems, so you're welcome to email me, contact me somehow if you need further explanation on that one. Okay, everything else should go maybe a little faster. Okay, let's look at number 7. Number 7 has 2 parts, each part worth 4 points. What's the ionization constant for HBr? So HBr is an acid, and it's going to split into its constituent ions. So that would be H+, and bromine is in column 7, so that'd be Br-. So to get K sub A, it's the products over the reactants raised to the coefficient. So this one is pretty simple. H+ times Br-. You do have to have the plus and the minus in there over the concentration of HBr. Most people did get that one. All right, part B on number 7 is H2CO3. All right, so that's going to split into, a lot of people miss this one, sometimes by just a little bit, sometimes by a lot, but it's going to split into a single hydrogen ion plus, so you reduce H2CO3 by 1, so you'd have H plus a proton plus HCO3, and when you take that proton away, it'll give this one a -1 charge. Okay, so K sub A is going to be the concentration of H plus HCO3 minus over the concentration of H2CO3. All right, if you did H2 there and CO3 2 minus, I didn't count off very much on that. I might have counted off 1 or 2 points. But a lot of people missed part B on this one. So each part worth 4 points for number 7. All right, let's look at number 8. All right, number 8 says the base ionization constant for C2H7N. Okay, this is a covalent base. It's not a hydroxide base. So with a covalent base, you add, as a reactant, liquid water. So a base gains a proton, so it's going to nab one of the hydrogens off the H2O. So that's going to be C2H8N. It'll be aqueous. And because it took a proton, it gives it a plus charge. And then plus OH minus. All right, sorry, I kind of put that a little too far to the right. That's OH minus and aqueous. Okay, so to get K sub B, it would be C2H8N. Don't forget the plus, concentration of that. OH minus And then we don't include the liquid, so only the C2H7N concentration. Okay, so I got crazy answers on number 8, and not many of you got that one right. But we did have some examples in the original lecture on this one. Okay, on a problems like this. So if you'd forgotten it, you needed to go back and watch that to get this one. This one was it's just one part, so just worth 4 points. Okay, I think I can get everything else on the board here. All of these easy ones at the bottom also worth 4 points. 9A, so 9 has 2 parts. What's the pH range for acids 0 to 6.9? I think every single person got that. As the pH gets smaller, does the acid get stronger or weaker? Well, a lower pH is a stronger acid. So an acid with a pH of 1 is stronger than an acid with a pH of 6. Almost everyone got that right. I think one or two people might have accidentally missed that one. All right, 10 says, what has the largest case of A pH of 1 or a pH of 6.5? So a larger case of A means a stronger acid. So of those two pHs, the stronger acid is the pH of 1.0. Almost everyone got that. Okay, number 11 has 2 parts. First, what is the pH range for bases? So that's going to be 7.1 to 14. As the pH gets larger, does a base get stronger or weaker? It gets stronger. Bigger pH for bases, so it's the opposite of acids. All right, stronger base. All right, and then number 12, which has the smallest case of B? So a smaller case of B means a weaker base. Okay, so a weaker base means a smaller pH, so that's a pH of 7.5. That's the smaller of the two numbers, so that would be the smaller case of B. Most people got that. Okay, each one of those parts is worth 4 points. So A is worth 4, B is worth 4. 10 is worth 4 by itself, it's just one part. On 11, A is worth 4, B is worth 4, and 12 is worth 4 by itself. Okay, so the whole thing adds up to 24 little parts, 4 points each, and I gave you 4 points just for breathing on that. Okay, on the math ones and these case of A and case of B, I could give you some partial credit, but on ones like numbers 4, 5, and 6, and then 9 through 12, I didn't give any partial credit on that. So that does it for the explanation. Please email me if you have any further questions. And who knows, maybe I'll make a video for the chapter 16 worksheet also. All right, we'll talk to you next video, or not.